So what are polymers? Polymers are large molecules built up by repetition of small simple chemical units, and these simple chemical units are called monomers, and these monomers are held together by covalent bonds. So monomers are repeating units present in the polymer, and polymer is a large molecule built by repetition of small simple chemical units called monomers, and these monomers are held together by covalent bonds. So when these monomers combine, what do you get? You'll get a polymer. So these monomers combine, and the force of attraction between these monomers, it will be covalent forces of attraction, covalent bond is formed, and that results in the formation of a polymer. So monomer is a molecule or segment of a molecular structure that is repeated many times in a polymer. And the term polymer is derived from the Greek words poly meaning many and meros meaning part. So what is polymer? Polymer means substance with many parts. Now what is polymerization? The process by which the monomers are transformed into a polymer is called polymerization. When it changes into polymer, that process is called polymerization. And in this diagram you can see examples for natural polymers: cotton, natural latex, from rubber trees, silk from silkworm, wood. All these are examples of chitin present in the shells of crabs. All these are examples of what? All these are proteins from eggs. All these are examples of natural polymers. So polymers നമ്മൾ നോക്കുമ്പോഴത്തേക്ക് നമ്മുടെ നൂഡിൽസ് പോലെ ആയിരിക്കും ഇരിക്കുക. അതിനകത്ത് ഒത്തിരിയേറെ ലോങ് ചെയിൻസ് കാണും. ഈ ലോങ് ചെയിൻസ് എല്ലാം തമ്മിൽ മിക്സ് ചെയ്തിട്ടുള്ള സ്ട്രക്ചറാണ് ഇതിനുള്ളത്, നമ്മുടെ പോളിമറിന് ഉള്ളത്. We'll see the classification of polymers. Polymers, they will have different chemical structures, physical properties, mechanical properties, thermal characteristics, etc. So they can be divided into four. The first one is natural and synthetic polymers. Second one, linear, branched and cross-linked polymers. Third one, homopolymers and copolymers. And fourth one, plastics, elastomers and fibers. Now the first one, natural and synthetic polymers, and on the basis of origin we can classify polymers into natural and synthetic polymers. Those polymers found in nature, mostly in plants and animals, are called natural polymers. Examples are starch, cellulose, nucleic acids, natural rubber, etc. Examples of natural polymers. And these polymers like starch, cellulose, nucleic acid, protein, etc. Control various life processes in plants and animals. So these polymers are also called biopolymers. Now the second one is synthetic polymers, and they are man-made polymers, and they are long chain organic polymers. Organic polymers are organic molecules containing thousands of monomer units. Synthetic polymers are long chain organic molecules containing thousands of monomer units. Examples are polythene, PVC, polystyrene, etc. And DNA is an example for natural polymer, and nylon is an example for a synthetic polymer. And on the basis of structure, polymers can be divided into three: linear, branched and cross-linked. The first one is linear, second one is branched, and third one is cross-linked. Now we'll see the differences between three. Linear polymers are polymers in which the monomers join together in a linear fashion to form long chains. So monomers, when they combine to form long chains, such type of polymers are called linear polymers, and these polymer molecules are closely packed. Different chains will be closely packed. So what happens to the melting point and density? melting point and density it will be high. So examples are nylon, polyester, high density polyethylene. All these are examples of linear polymers. Now the second one is branch polymers. Now what are branch polymers? They form branch chain along with the linear main chains. Branch polymers, they'll be having branch chain along with linear main chains, and these polymers are not closely packed. Branch chain polymers are not closely packed, so that's why their melting point will be low and also density will be low. Examples are starch and low density polyethylene. So these two examples of branch polymers. And the third one is cross-linked polymers. Cross-linked polymers are three-dimensional network polymers. And how are they formed? The monomer has 3 or more reactive sites. The monomer that we use, if it has 3 or more reactive sites, what happens is that it first forms a linear or branch polymer. Then these linear polymers, they form cross links, and that leads to the formation of cross-linked polymers. So linear or branch polymers first form, link to give cross-linked polymers. So here you can see this is an example for cross-linked polymer. You can see cross-links between different polymer chains. So that's an example for a cross-linked polymer. Bakelite, melamine, formaldehyde, resinol, these are examples of cross-linked polymers. Now the third one is homopolymers and copolymers, and based on the type of repeat units, you can classify polymers into 2: homopolymers and copolymers. What are homopolymers? They are obtained from one type of monomer units. Here you can see only one type of monomer unit is present in this particular polymer. So this is an example for a homopolymer. Example is polythene. In polythene, the monomer unit is ethylene. So when ethylene combines, you will get polythene. Second one is copolymer, and it is obtained from different types of monomers. Here you can see different types of monomer units. When different types of monomer units combined, what do you get? You will get a copolymer. Example is nylon 6,6. Nylon 6,6 contains 2 different types of monomer units. So that's an example for a copolymer. Now again, this copolymer can be divided into random, alternating, block and graft copolymer. First one is random. From the name itself we can say here the monomer units are arranged randomly, also known as irregular polymer. Here you can see random copolymer, monomer units arranged randomly. Second one, alternating. Monomer units are arranged in a regular manner and distributed alternatively along the chain. And so here you can see it will be in the arrangement of monomers, it will be in a regular manner, but the monomer units, it will be alternate. Now the third one is block copolymer. Here the linear molecules in which monomer segments on the backbone and branches are not the here you can see that along the linear along the polymer chain, blocks of homopolymer units. അപ്പോൾ നമ്മൾ ഈ ബ്ലോക്ക് കോപോളിമർ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താ മെയിൻ ആയിട്ടുള്ള ചെയിൻ നമ്മൾ എടുക്കുമ്പോൾ അവിടെ എങ്ങനെയായിരിക്കും, അവിടെ ബ്ലോക്ക് ആയിട്ടാണ് മോണോമർ യൂണിറ്റ്സ് നിൽക്കുന്നത്. ആദ്യത്തെ മോണോമർ യൂണിറ്റ് ഒരു ബ്ലോക്ക് ആയിട്ട് നിൽക്കും, രണ്ടാമത്തെ മോണോമർ യൂണിറ്റ് ഒരു ബ്ലോക്ക് ആയിട്ട് നിൽക്കും, അങ്ങനെ. ഇനി ബ്രാഞ്ചസ് ഉണ്ടെങ്കിലും ബ്രാഞ്ചസിലും ഇതുപോലെ ബ്ലോക്ക് ആയിട്ടായിരിക്കും മോണോമർ യൂണിറ്റ്സ് നിൽക്കുക. Linear molecules in which monomer segments on the backbone and branches are not the same. Now the fourth one is graft. Grafting fragments of one polymer over another polymer. അപ്പോൾ ഇവിടെ ഗ്രാഫ് പോളിമർ നമ്മൾ എടുക്കുമ്പോഴത്തേക്ക് എന്താ കാണുന്നത്, ഒരു പോളിമർ ചെയിൻ കാണും, അതിലേക്ക് മറ്റൊരു പോളിമർ ചെയിൻ ഗ്രാഫ്റ്റ് ചെയ്ത് വെച്ചിരിക്കുകയാണ്. അപ്പം അങ്ങനെയുള്ളതിനെയാണ് നമ്മൾ copolymer എന്ന് പറയുന്നത്. ബ്ലോക്ക് കോപോളിമറിനകത്ത് നമുക്ക് മെയിൻ ചെയിനിനകത്ത് ഡിഫറെൻറ്റ് ബ്ലോക്സ് കാണും, ഡിഫറെൻറ്റ് മോണോമർ യൂണിറ്റ്സിൻ്റെ ബ്ലോക്സ് കാണും. ബ്രാഞ്ചസ് ഉണ്ടെങ്കിൽ ബ്രാഞ്ചസിലും അതുപോലെ ബ്ലോക്സ് കാണും. ഗ്രാഫ് കോപോളിമറിനകത്ത് മെയിൻ ചെയിനിൽ ഗ്രാഫ്റ്റ് ചെയ്ത പോലെ മറ്റൊരു മോണോമർ യൂണിറ്റ് അറ്റാച്ച് ചെയ്തിട്ടുണ്ടായിരിക്കും. അതാണ് ഇത് തമ്മിലുള്ള ഡിഫറൻസ് എന്ന് പറയുന്നത്. Now the fourth one is plastics, elastomers and fibers, and this classification is on the basis of intermolecular forces. And the first one is elastomers, and elastomers exhibit good strength and elongation. So when we apply force, we can move apart the polymer chain. So here you can see the intermolecular forces. It will be weak between polymer chains. So that is why it exhibits good elongation. It has good strength and elongation, and it is an example for a amorphous polymer. The arrangement is not regular. The arrangement of polymer chains or molecules is not in a regular manner. So that is why elastomers are amorphous. And the second one is fiber. They are thread-like polymers, and they will be having high strength, and they have the strongest intermolecular forces. There will be a regular order in the arrangement of atoms, so it will be crystalline in nature. And examples are nylon 66 and terylene. Fibers examples are nylon 66 and terylene. And plastics, they will be having intermolecular forces between those of elastomers and fibers. Plastics will be having intermolecular forces between those of elastomers and fibers. And these plastics can be divided into two: thermoplastics and thermosetting plastics. And based on response to stress and temperature, these polymers are classified into thermoplastics and thermosetting plastics. Now we'll see the differences between thermoplastics and thermosetting plastics. Thermoplastics are usually formed by the addition polymerization. The difference between addition polymerization and condensation polymerization we will discuss in the next class. And thermosetting plastics are often formed by the condensation polymerization. And thermoplastics are usually long chain linear polymers, and these linear polymers are held together by weak van der Waals forces of attraction. So many linear polymer chains will be there, and these polymer chains are held together by weak van der Waals forces. Thermosetting plastics, it will be having a three-dimensional network structure, and these network structures are formed using covalent bonds. And the third difference is, when you heat this, what happens? It becomes soft and it stiffens on cooling. But thermosetting plastic, it does not become soft on heating. You cannot remold the thermoset plastic. Thermoplastic is soluble in organic solvents, but thermosetting plastics are insoluble in organic solvents. Why? Because you can see cross-links between different polymer chains. And thermoplastics are usually soft, weak, and less brittle in nature. But thermosetting plastics are hard, strong, and more brittle in nature. They can be remolded thermoplastic, but thermosetting plastic cannot be remolded. And thermoplastic example is polythene. Thermosetting plastic, the example is bakelite. So these are the differences between thermoplastic and thermosetting plastics. So the classification of polymers, there are 4 types. The first one is natural and synthetic polymer. Second one is homopolymers and heteropolymers, and third one is linear, branched and cross-linked polymers, and fourth one is elastomers, fibers, and plastics.